Hi, I am Naveenkumar from SA Engineering College. We are going to see about data structures. Data structures having two types of data. First one is about linear data structure and next one is about non-linear data structure. First, initially we will see about linear data structures, arrays, queues and stack. Linear data structure is nothing but the data arranged in a linear sequence. Data items can be traversed in a single run. The data structure elements are assigned in a place of together in a sequence of memory location. First, initially we will see about a stack. Stack is nothing but the concept of last in first out. Initially, that means the last thing is added or pushed first, it will be removed first. It is sequence of item accessible at one end of the sequence. For examples, this is the examples of a stack. We are arranging books in one by one. First, lastly added book will be removed first. Or a plate. These two things are examples of a stack. The operations of stack is push and pop operations. Push is nothing but inserting an element in a stack, and pop is nothing but deletion of an element. For insertion and deletion, top pointer will be used. Top. For example, I want to insert, I am already having an A, B and C element inside the stack. So I want to insert a new element D, means we have to give the instruction as push D, and next element E, push E. Pop is nothing but deletion item from the stack. If you want to remove any item from the stack is nothing but pop. Its D is removed. We are having only A, B, C in the stack. For that one, the top pointer is used. Algorithm for insertion of an element. For push operation, that means insertion of an element by using a top pointer. For example, I want to insert a element D in a stack. For that, we have to check whether the stack is overflow or not. Overflow is nothing but whether the stack is fully loaded or not. For example, I am using a top pointer. We have to check whether the top equal to max. Maximum means all the data are saved. The memory is already allocated inside the stack. Stack, if the top equal to max, we have to print as stack overflow, or else we have to increment one place of an pointer. If I incremented one place, means we have to push a D. Then we have to insert a element and we have to move out. Then next one is about deletion operation of an stack. We have to check whether the stack is having some data or not. If top equal to 0, this top pointer is equal to 0, we have to print stack underflow. That means there is no element in the stack. Then move out, or else top equal to top minus 1. We have to minus 1 means it needs to goes down, or decrement 1 and delete that item. Then exit the loop. These are all the applications of an stack. Reversing a string. This is a simple application, is reversing a string. To reverse a string, the character of the string is pushed onto the stack one by one, as the string is read from left to right. Once all the characters are inserted into the stack, and we need to remove one by one and add the data in a linear format. This is the example of an reverse the string. I am having a string reverse. I need to reverse this string. First, I have to insert R, E, then B, then E, then R, and then S. This is the inserting and pushing an item in the stack. The next one is about pushing an item in the stack. If you pop out, the last inserted will be removed first. This will be arranged in E, S, R, E, V, E, R. This is the reversing and string. The next application will be arithmetic expression, infix notation, prefix notation and postfix notation. This goes under the format of BODMAS rule. BODMAS is nothing but brass of multiplication, division and addition and subtraction. Initially I am having an a plus b in a half bracket. First we have to do the operation inside the bracket. This one is an infix notation, example of an infix notation. We have to convert this one into prefix. Prefix means we have to go for an BODMAS rule. Then there is only one symbol of, inside the of only we have to perform the operation by using an operator. Here the operator will be only one operator is addition. Prefix means in front of an operand we have to put the operator. Then plus AB. Postfix is nothing but after the operand there is an operator is the postfix operation. Then conversion of an infix to postfix conversion. Then I want to convert that infix into postfix operation. First one, the step one I am inserting, I need to perform the off operation. I have inserted 4 minus 1 off. Inside the bracket we have to perform the operation 4 minus 1, 4, 1 and minus into 3. This is the first step. Then second step will be we go for an BODMAS rule. First we have a multiplication. We already performed this operation. Then into 3 I am having. Multiplication is the next one. Then 3 multiplication symbol. And then next operation I have to perform 2 plus 4 minus 3 star. Then I have to perform this operation. I have to move the last place of plus symbol. So this is the example of an infix to postfix conversion. This is the symbolic representation. I will get the value of an 11 if you perform a infix to postfix conversion. The next one is about queues. Queues is nothing but this, we are inserting an element in one end and removing an element in another end. There the two operations will be performed in a queue. First one is about insertion of an element and next one is about deletion of an element. Insertion is said to be as an NQ and deletion is said to be as a DQing. For NQing an element, it will be done in the rear end. Rear means front end. For DQing an element, it will be done in a front end. That means last part. Removing of an element. Algorithm for inserting a element in a queue. First we have to check whether the size of the queue. If the size of the queue is -1, we have to print queue is overflow. That means data is already filled in a queue. Or else we have to increment the rear pointer +1 and insert the data item. Then dequeuing an element means the deleting an element for an algorithm for deleting an element. If front equal to rear, print the queues is empty and move out of the loop. Front equal to rear is nothing but there is no element in a stack. Front and rear pointer is in a same place. Front equal to front +1 is nothing but you are removing an element or item from the stack, queue, the memory space. Queue application will be there is in a real life examples. Waiting in a line is the one of the application, or waiting on a hold of tech support. For example, you are calling a telecaller, you are a waiting list. Then first one, first serve. Is basis the queue will be worked. The application will be in round robin scheduling, job scheduling and keyboard forward. These are the applications of an queue. Then there is the 3 states of operation in the queue. Queue is empty means you will say front is equal to rear. Queue is full, rear equal to n. That means n number of data are already stored in a queue. Queue contains greater than equal to 1, front less than rear, the number of element is equal to rear minus front plus 1. How many elements in the queue? This is the syntax. Then next one we are going to see about linked list. Linked list is a linear data structure which elements is not stored in a continuous memory location. The elements in the linked list are using the pointers. The pointer, the memory space of the next node will point the data of the next node. That means the memory space of a pointer will point the next node data. This is said to be as an node. Thus the basic operation will happen here is insertion, deletion, display, search and delete operation will be performed in the linked list. The types of linked list will be 3 types: singular linked list, doubly linked list and circular linked list. Singly linked list is having only one pointer. That means in a first node, the next node memory pointer will point the data. Then the first node is the first part is a data, that one is said to be as an hand. The second part is a address part. That means that address part will point the next node data. Then first one node is said to be as an head and last one is said to be as an null, because the second part of the last node there is a no memory address, so that way it is said to be as a null point. Then next one is about doubly linked list, which have each part from storing a data has 2 links. That means the first link points to the previous node in the list and second link points to the next node in the list. The first node of the list, it has a previous link pointing to null. Similarly, the last node in the list has next node pointing to the null. That means the address of the previous pointer has in 2 ways of the pointer. That way it is said to be as a doubly linked list. Then next one is about circular linked list. Circular linked list is a sequence of an element which every element linked to its next element in the sequence, and the last elements having a link to the first element of the list. So that means the last node address points the first node data. That's why it is said to be as a circular linked list. Then the advantages of circular linked list will be repeatedly need to go around the list, used to implementing data structures like Fibonacci heap. These are all the advantages of a circular linked list. Then the disadvantages will be in the linked list, memories is wasted as pointers requires extra memory for an storage. No elements can be accessed randomly. We are not able to access the elements randomly in a linked list. Reverse transferring difficult. Reverse transferring, that means transferring of a string is difficult in a linked list. These are all the applications of a linked list: polynomial representation, symbol table creation, mailing list, memory management. All the things are applications of a linked list. Then we'll go for some gate questions. First one, the best data structure to check whether the arithmetic expressions are balanced parentheses or not. We already seen the example. You know it very well. Stat is the answer for this question. Then we will go for the next question. Which of the following is true about linked list implementing of an stack? In a push operation, if new nodes are inserted at the beginning of an list, then pop operation nodes must be removed from the end. That means the question is true about linked list implementation of an stack. Then push operation, if new nodes are inserted at the beginning of the list, then pop operation, that means we are remove node from any place in the middle or in the front and in the Right. Push operation, if new nodes are inserted at the end, the pop operation node must be removed from the beginning. We can push anywhere, we can pop anywhere. These two are false. Then both of the above means we have to adding these things. Then none of the above is the answer for this question. Then question 3. The queue is implemented using an array such that NQ and DQ operation are performed efficiently. Which one of the following statement is correct? Both operation can be performed in big O of 1 at a time. Most operation can perform big O of 1 time, but worst case time the operation will be pi of n. Then the worst case is complexity, the operation will be none of n. The worst case time, then the answer will be both operation can be performed in big O of 1 time. Thank you. Thank you for watching this video. We will see the remaining topics in next class.